Greetings, ladies and gentlemen. It's my honor to introduce our paper to all of you. And my name is Jiarun Fu, the author of this paper. Okay, let's begin with our paper's title. Our title is Enhanced Network Module Generative Adversarial Network for Low Light Image Enhancement. We can see the target problem that we want to solve is for the low light image enhancement, and we are trying to combine the enhanced network module with the generative adversarial network to solve this problem. Okay, below the title is the information of the author of this paper. We can see that it's me and this other author. And of course, thanks to the AIMEE 2020, uh, thanks to the fourth International Conference of Artificial Intelligence in Medical Energy Education. Thanks for giving this opportunity for us to introduce our paper to all of you. Okay, let's move. The first part, of course, is the research background. With the introduction of deep learning into the field of image enhancement, combined with the traditional enhancement algorithm, the performance of the algorithm has become more excellent. However, the enhancement of low light image have not been completely solved by the introduction of deep learning. So we introduced the enhancement network module into the generative adversarial network, aiming to form a network module that can effectively solve the problem of low light image enhancement. Through the experiments, we prove that the algorithm have outstanding performance in the text field. That's the background. That's why we choose the low light enhancement problem as our target, and it's overall view that how we solve this problem. Okay, let's move on. The next part is the methodology. I have to say it's to be honest, is the most important part in this paper. It's to explain the math that we solve our target problem. Okay, in order to enhance the transmission of weak light position information of the uh, image in the network flow, the generator is an enhanced network. The enhanced network converts the input image as a whole into a similar image in the new space, and the attention network predicts the position mask of weak light, which is the same size as the input image, with each pixel having a probability value between 0 and 1. Finally, we combine the input image and note that the force diagram and the transformed into constitute the final enhanced image. The discriminator can receive both the generated image and the real image, and finally produce the predicted value of true and false. It's the method that we choose to solve the problem in our paper. And the next part, I'll try to explain the basic technology uh, of our paper. Of course, it's the generative adversarial network. We can also call it GAN. GAN generative adversarial network was proposed in the October 2014. And it put forward a process through the convolution in the estimated to generate a new framework of model. And in its framework, there are two parts. We can see the green part and the red part. For uh, the green part, we can call it the generation model G, which captures the data distribution. We can see this one is the green part, and for the red part, we can call it the discriminant model D, the red part, and we can also call it discriminator, which estimates the probability of the sample from the train data. Of course, there are also a math meaning to the generative adversarial network. We can see the formula, and under the formula is the meaning of the parameter of this formula. We can see that. Okay, move to the next part. Okay, we can at first we just see this picture, the schematic diagram of the generate network structure. We can see the most obvious part in this picture is the orange part, the residue unit. We add the residue unit into the network to generate a new form network. Why we choose the residue network? Because residue network have been proved to be effective in many fields, such as object dedication and image segmentation. This operation, this operation residue connection to train deeper network and avoid feature loss by introduce residue into the block. So after we add the green part into our network become more deeper than before and avoid some mistakes. Okay, and then is the next part. It's the diagram of the discriminator network structure. It's the part we can see. It's the information about the structure of this network. I think we don't need to explain more of this part because it's very obvious from this picture. Okay, let's move to Martha. Of course, we have the loss function. This loss function means the max min of our new net our our network. We can see the formula, and for the parameter in the formula LA, the mean is loss of attention, and we can see it's same to the other parameter in this formula, and this one is also explains the other parameter in this formula. Okay, let's move. And the next part is we should explain the total total structure of our network. The blue block is shown in the future in the image. In the picture, the first layer is used for feature extraction to achieve multiply feature from RGB channel. We can see that it's that part. And the orange block in the filter restraint residue cell is this part. And for the last two layers are used to reduce RGB image to achieve multiply filter conversion to RGB image. We can see that. And below the picture, we can also see another formula of this loss function. It's a highlight point in our paper. Because the input and the target image cannot be closely matched, different optional elements and synthesizer will cause certain local nonlinear discrimination and the aberration, and even after accurate elegant, there will be an unsteady shift in the number of the pixels between each image pair. Therefore, the standard pair loss expected for the private quality indicator. So overall, we propose a new loss function. Is that one? We can see that. Okay, and then the flow of our algorithm. We can see that we have about 10 steps to achieve our algorithm. And for the next part is the element for our paper. We can see the result. There are 6 different pictures in the first example, and compared to the other algorithms result, our is more likely to the real image, and it seems to the second part. In this 6 picture, our result is also the more excellent. And for the algorithm that we compare with, the HENSR is the traditional enhancements, and the DSR is the deep learning enhancements. And for the next part, uh, we use the PSN and SIM indicates represent a comprehensive assessment of the clarity and the robustness of the image restoration, and we can see the result compared to the number. Uh, our algorithm is the most has the most excellent result in the robustness and the clarity. Okay. So after the experiment, we can know our algorithm is more excellent than the enhancement than before to solve the low light enhancement problem. And we can get the conclusion. In this article, we introduce the enhancement network module into the generative adversarial network to solve the problem of low light image enhancement. The enhanced network use residual connection to build residual modules and join the generative adversarial network to deepen the network, thereby improving the ability of image enhancement modeling. In the experimental stage, we conducted a comparative experiment with traditional image enhancement methods and deep learning enhancement methods, which prove that our algorithm have obvious advantage in the reduction and robustness of enhanced low-light image problem. In the future, we will conduct more large-scale experiments to further prove the general validity of our algorithm. That's all. Thank you. Thank you for all of us. So thank you for all of you.